In this video, we're going to talk about work in thermodynamics. The state of any thermodynamic system can be described with the internal energy. The internal energy U of a thermodynamic system can be changed in two different ways: adding heat, Q, to the system, or doing work, W, on the system. In 1845, James Joule presented his paper on the mechanical equivalent of heat. He was the first to discover that doing work on a system increases its temperature. A simple example of a thermodynamic system is a quantity of gas enclosed in a cylinder with a movable piston. Consider the work done by the gas during its expansion. Note, the work done will be positive since the pressure, which is the force per unit area, and the motion of the piston are in the same direction. Remember, work is equal to F dot D. Since both the force and the displacement are in the same direction, the work will be positive. So here, if we take the piston, and the piston is moved by the pressure of the gas, which is directly proportional to the force and the displacement of the piston are in the same direction, and therefore the work is done by the gas, which is positive. The work done on the gas is going to cause the force on by the gas on the piston to be in the opposite direction of the motion of the piston, and therefore the force exerted by the gas is going to be in the opposite direction of the displacement, and therefore the work will be negative. Suppose that the cylinder has a cross-sectional area A, and the pressure exerted by the gas is called P sub gas. The force exerted by the gas on the piston is F, which is equal to the pressure of the gas times its cross-sectional area of the piston. When the piston moves up a distance delta x and the pressure is constant, the work W is equal to F delta x, which is equal to the pressure of the gas times its cross-sectional area of the piston times delta x, or work is equal to P delta V. When the piston moves down, the gas volume decreases, and so the work done by the gas is negative. During the compression of the gas, the work W prime done by the external force F external is going to be positive. So the work done external to the gas is going to be P delta V, which is going to be positive. The relationship between the work done by the gas and the work done on the gas can be represented by the following: that the work done on the gas is equal to negative W, where W is the work done by the gas. This relationship can be represented as a graph of P as a function of V on a PV diagram. The work done equals the area under the curve on a PV diagram. So you take the pressure times the change in volume, and that equals the work done. In an expansion, the work done by the gas is positive because we're taking the pressure times the volume at point B minus the volume at point A, and since the volume at point B is larger than the volume at point A, we end up with a positive area. In other words, the area is going to be positive multiplied by a positive pressure gives us a number greater than 0, and the work done by the gas is positive. The work done equals the area under the curve on the PV diagram. In a compression, the work done by the gas is negative. Notice the arrow goes from volume B to volume A. So we take the change in volume. So we take the volume at A minus the volume at B. Well, that's going to give us a negative number because the volume at A is less than the volume at B. Therefore, multiplying that by the total pressure, that gives us a number less than 0, which means that the work done by the gas is going to be negative during a compression. So let's go ahead and practice. The state of an ideal gas is changed in a closed path from points 1 to point 2 to point 3 to point 1 again. Which of the following is true about the work done by the gas between point 1 and point 2? The work done by the gas is positive. The work done by the gas is negative. The work done by the gas is 0. The work done by the gas is greater than the work done on the gas. The work done by the gas is less than the work done on the gas. Go ahead and select your answer now. Okay, so let's check and see what the correct answer is. The correct answer is C. No work is done in this case because the volume remains constant. It doesn't change. The state of an ideal gas is changed in the closed path from 1 to 2 to 3 to 1. Which of the following is true about the work done by the gas between points 2 and 3? The work done is positive. The work done by the gas is negative. The work done by the gas is 0. The work done by the gas is greater than the work done on the gas. The work done by the gas is less than the work done on the gas. Okay, so let's see if you've selected the right answer. Go ahead and pause the video if you need to. The correct answer is A. The volume is increasing along the isotherm. The area under the curve will be positive, and therefore the work being done by the gas is positive. The state of an ideal gas is changed along a closed path X to B to Y to A and to X again. What is the total amount of work done by the gas? Is it A, 2 PV? Is it B, negative 2 PV? Is it C, PV? Or is it D, negative PV? Pause the video now if you need to. Okay, so let's take a look at the correct answer. The correct answer is C, and here's why. You have to figure out the work done along the area under X to B, and that's going to be 2 PV. So from here to here, we're going from a larger volume to a smaller volume. We're taking 2V minus V, and that gives me V, and we're multiplying that by 2P, which gives us 2 PV. The work done along the area from Y to A, from here to here, is going to be V minus 2V, which gives me negative V, times P. So that's going to be negative PV. Okay, so then the net work is going to be 2 PV plus negative PV, which gives me PV. In the next video, we'll talk about the first law of thermodynamics.